In this video here, we're going to take a look at the flow of an activity. Now we can determine the total flow of activities. Now the total flow of an activity is the amount of time that its start may be delayed without affecting the duration of the project. So in that case, then the total flow is equal to the latest finish time minus the duration minus the earliest start time. And the total flow of any critical activity is always zero, and that's an important point there to be aware of. Now, before we work through a practice question together here for the flow of an activity, let's just quickly demonstrate some examples here for calculating the flow of an activity. And then finally, to finish with here, let's just run through 3 examples then for finding the flow of an activity. Now, for the first example here, then this is for activity A. And what you should hopefully recognize here is A is a critical activity. So what that means then is the total flow here for activity A is just simply 0. Don't forget then, any critical activity has total flow of 0. Okay, so hopefully nice and straightforward. Now for the next example here, activity B. Again, I've got my diagram here from a network. Now, activity B then will have total flow of the following. So I've got 10 here, the latest finish time, minus 2, the duration, minus 5 here, the earliest start time. So 10 minus 2 minus 5 is just the same as 10 minus 7. And that just simply gives us 3 there. So activity B has total flow of 3. And then finally, for the very last example here, activity C. Again, I've got my diagram here, as we can see on the screen. Now, activity C then will have the following total flow here. So I've got 18 then, the latest finish time, minus 5, the duration, minus 6 here, the earliest start time. So 18 minus 11, that just simply gives us 7 there. Okay? So there we have it then. That concludes this introduction here to the flow of an activity. So to finish with then, let's just work through one practice question together. So for this question here, what we've got then is an activity network. So this diagram here represents an activity network for a project. The number in brackets on each arc gives the time taken in days to complete the activity. So we can see our activity network here. The early and late event times have been completed for us. And all we want to do here then is just find the flow for each activity. So hopefully nice and straightforward, right? Now, we've already kind of covered this in the previous video on critical activities, but we'll just run through this anyway. Should be nice and straightforward. So before we begin here, let's just make a quick point here then. So to find the total flow here for an activity, so total flow is equal to, so it's the late event time, which I'll abbreviate to LET. So late event time minus the duration. So minus duration minus the early event time. And again, I'll abbreviate this here to EET. Okay? Just using this result here, then we can easily calculate the total flow for any individual activity. Okay? So like the question says then, all we want to do here is just find the flow for each activity. So let me just write down then the activities. So I've got A, B, C, D, and we go up to H here. So E, F, G, and H. Okay. And then to the right here, I will do the flow. Okay. So this here is the flow. I'll just box this off here like so. Really, I should be using a ruler here, but I'm being lazy. In an exam though, don't be lazy. Use a ruler, right? Anyway, I digress. So for the flow then here, let's just begin with activity A. So the late event time here is 4. So I do 4 minus the duration, which is 3, minus the early event time of 0. So 4 minus 3 is 1, 1 minus 0. That just gives us 1 there for the flow of activity A. So activity A then has flow of 1. What about activity B here? So the late event time is 5, minus the duration, which is also 5, minus the early event time of 0. So I do 5, minus 5, which is 0, minus 0, and we get 0 there. So activity B has a flow of 0. In other words, activity B is also a critical activity. So for the next activity here, activity C, my late event time is 8, minus the duration, which is 4, so 8 minus 4 is 4, minus the early event time of 3. And we obtain here then that the total flow for activity C is also 1. Now for activity D here, the late event time is 8, minus the duration, which is 2, so 8 minus 2 is 6, minus the early event time, which is 3. So 8 minus 2 is 6, 6 minus 3, we get 3 there. So the total float here for activity D is 3. Now for the next activity, that is activity E here, my late event time is 8, minus the duration, which is 3, so 8 minus 3 is 5, minus the early event time of 5. So the total float there is simply 0. Now for activity F here, so my late event time is 14, minus the duration here, which is 5, so 14 minus 5 is 9, minus the early event time of 7. So 9 minus 7, and we get 2 there for the total flow of activity F. We're nearly done here, right? Just 2 more activities to go then. So for activity G here, my late event time is 14, minus the duration, which is 6. So 14 minus 6, that gives us 8. We then subtract the early event time, which is also 8. So in that case then, 8 minus 8, we get a total float of 0. So again, activity G here would also be a critical activity. And the same is true here for E. I can't remember if I did mention it or not, but anyway, just so you're aware here, activity E would also be a critical activity. And then finally, for the very last activity here, activity H, so my late event time here is 16. So 16 minus the duration, which is 2, that gives me 14, minus the early event time of 14. So 14 minus 14 is 0. And again, activity H here is also a critical activity. Okay? And there we have it then. So what we've done there is found the float for each individual activity. And that gives us the solution then to the one practice question for this video. And that brings us to the end then of this video here on the flow of an activity.